And welcome back once again. This is Mr. Spinks. We're in section 2.3 now, and we are talking now about Venn diagrams and how they relate to sets. And I think you guys have done Venn diagrams before, but we're going to go through it all just to make sure you're good. This first video we're talking about is really about this one right here, how Venn diagrams relate to sets, and then we're going to talk about this idea of complement. The rest of them will come up in later videos. Starting off, what is a Venn diagram? Basically what a Venn diagram is a way of representing a set as well as the relationships among sets using circles. So there are different types of sets we're going to be talking about here that I need you to be aware of, and I'm using Venn diagrams down here to help you to understand them. First of all, the box around every one of these Venn diagrams has a U in the corner that indicates it's the universal set. That's all the elements for all the discussion going on here. Now you'll see two circles in each one of these guys, okay? Here we go. Talking about disjoint sets. Disjoint sets are sets that share no elements. So if we said this right here was set A, and this was set B, notice how they don't overlap at all, therefore none of the elements of A are going to be in B. That's what disjoint means. We've talked about subsets. What subsets means is all of the elements of one set are elements of the other set. So if we made the outside set set B and the inside set set A, that indicates that all of the elements of A are inside B. Therefore A is a subset of B. Moving on, we have equal sets. This should be obvious. They have the exact same elements. Well, how is that represented on a Venn diagram? Well, it's represented as two circles that are the same exact thing. You'll notice how all the other ones have two different circles. That's because they are different sets, but these two equal sets are the same. That's why there's only one set. So I will put an A over here and a B over here and tell you that this circle right here is both A and B because they're the same thing. Final one. Final one are overlapping sets. These are sets that contain some common elements but aren't equal. So it's not going to be one circle. It'll be two different ones, but they will overlap. Notice how they overlap here in the middle. I'll make this set A and this set B. Whoop. And therefore, that's not necessary over there. These two sets will overlap in this particular case. Let me put my B back on here just for good measure. There he is. All right, moving on to the next example. So we've kind of set up what a Venn diagram is as well as some characteristics of Venn diagrams. We're going to move on at this point in time to complement sets. So a complement set. Now, what a complement set is the set of all the elements in the universal set that are not in set A. Now, we denote this a certain way, so you're going to have to know how this is denoted because this is how I'll ask it on a test. It is denoted as A prime. This little marker up here in the corner indicates they want the complement set. Now I'm going to use a Venn diagram to make this a little clearer for you. So the complement is the set of all the elements in the universal set. The box is the universal set, but they cannot be in A. So if I'm going to shade what the complement of set A is, it would be this outside region out here, outside of set A, because those are all of the elements that are still in the box, that are still in the universal set, but are not in set A. And we'll use a couple of examples to help illustrate this. All right, given that the universal set is 2, 4, 6, 8, 10, and 12, and 14, and A is 4, 8, and 14, I want the complement of A. Well, the complement of A is all of the elements of the universal that are not in A. So I see a 2, and I can just knock them out right here. There was a 4, an 8, and a 14, and I'm going to write the rest of them down. I've got a 2, a 6, a 10, and a 12 for the complement of set A. Pretty easy stuff. Moving on to the next one. U is the set of all natural numbers less than 8, and A is 1, 2, or 1, 5, 6, and 7. Well, I'm going to write out what the universal set is to make my life a little easier. I hope you remember natural numbers means that they are positive numbers and they cannot be 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, those are natural numbers. Our natural numbers must be less than 8. So 1, 2, 3, 4, 5, 6, and 7. We will not include 8 because it's got to be less than 8. Now I'm going to try to find the complement of set A here. So I'm going to mark out all of those in the universal set that are in A. So 1's gone, 5's gone, 6 is gone, 7's gone. Whatever's left is going to be the complement of A. Well, if we look, the complement of A, therefore, is going to be 2, 3, and 4. This has been a video about complement of sets as well as an introduction to Venn diagrams.